So for this one, we're going to do the partial fraction decomposition of x squared over x to the fourth minus 1. Whenever doing partial fractions, it's important to have the denominator factored. So we will write this as x squared over x squared minus 1, x squared plus 1, using the formula for the difference of two squares. And that's equal to x squared over x minus 1, x plus 1. Let me switch, that's all right. And then x squared plus 1. Okay, now the form of the decomposition, this will have the form a over x minus 1 plus b over x plus 1. And then here I have an irreducible quadratic, and so that'll have the form cx plus d over x squared plus 1. So real linear terms will have a constant. Irreducible quadratics, the numerator will be a linear thing. Okay, now the technique is that we will clear out the denominator here, and I'll start that down here. So if I multiply through by the denominator, on the left side I'll have x squared. On the right side I'll have a times x plus 1, x squared plus 1. The x minus 1 would cancel. Then I would have b times x minus 1, x squared plus 1. The x plus 1 cancels. And then last, cx plus d times x minus 1, x plus 1. All right, so now we plug in. So two things we can do. Number one, we can multiply out and match coefficients, and we get a 4x4 system. That works, but that's extremely painful. What's a whole lot easier is to plug in numbers. So if I plug in, say, -1, then I would have 1 is equal to, if I plug in -1, this term goes away. Then I would have b times -2 times 2. And if I plug in -1, then this term goes away. So I end up with simply that 1 is equal to b times -2 plus 2, so that b is equal to -1/4. Next, I can also plug in 1. That's another easy number to plug in. If I plug in 1, I get 1 equals, here I would have a times 2 times 2. If I plug 1 into this, I get 0, so that goes away. If I plug 1 into this, I get 0, and that goes away. And so I get a is equal to 1/4. Okay, now I've run out of the best things to plug in. Now, from this point forward, I have two options. I can multiply out and match coefficients. Another option is I can simply plug something else in. So let's plug in 0. Plugging in 0, here I would have a is equal to 1/4 times 1 times 1. Then if I plug in 0, I have plus or minus 1/4 times -1 times 1. If I plug 0 in here, that goes away, and I end up with d times -1 times 1. And so I can bring this d over to the other side, and so d will be equal to 1/4 plus 1/4, which makes 1/2. All right, and last, we can plug in something else. So let me plug in 2, just to have something that's relatively simple to plug in. Plugging in 2, I would get 4 is equal to a times, well, actually, a is already found to be 1/4. Plug in 2, I get 3. Plug in 2 here, I get 4 plus 1 for 5. Then I have minus 1/4. Plug in 2, I get 1. Plug in 2 here, I get 4 plus 1 makes 5 again. Then if I plug in 2, I get 2c plus 1/2 times 1 times 3. Now that's a bit long, but there's only one variable here, c, so I can solve for it. Okay, so I get 4 is equal to 15/4 minus 5/4 plus 3 times 2 makes 6c, then plus 3/2. All right, so here I have 10/4, which is 5/2, plus 3/2 makes 4. So that cancels. I get 0 is equal to 6c, so that c is equal to 0. So there are my answers. C equals 0, D is 1/2, A is 1/4, B is -1/4. And so coming back up here, we find that A was 1/4, over x minus 1, then minus a fourth over x plus 1. C was 0, and D was a half. So plus 1/2 over x squared plus 1. And that is the decomposition of this rational function.